welcome to Gifted's Science and Technology Physics class. My name is NC Joshua. Today we'll be looking at electromotive force. What is electromotive force? Electromotive force is the potential difference. Take note of this. Is the potential difference of the cell when it is not delivering current. So what is a cell that is not delivering current? Take note of this. One is not delivering current. We said such a cell is an open circuit. We have various types of circuit. We have a closed circuit, we have an open circuit, we have a short circuit. So an open circuit is a circuit that is not delivering current. So EMF is the potential difference of the cell when it is not delivering current. That is, it is the open circuit. Now, another way again you can know what is this. We said it is the maximum potential difference an electric cell can deliver. It is the maximum potential difference an electric cell can deliver. That's EMF. Now, what about potential difference? PD. What is potential difference? We said potential difference is also called voltage. Now, it is the difference in electric potential energy. It is the difference in electric potential energy per unit charge. Take note of this word. Energy per unit charge is either called EMF or voltage. Energy per unit charge, that's the formula. So I can say EMF is equals energy over charge. Take note of that. Or voltage equals energy over charge. Take note of these formulas, very important. So potential difference is the electric potential energy, is the difference in the electric potential energy per unit charge between 2 points in an electric circuit. That's potential energy, potential difference. Now come over here. It can also be the work done. Take note of this is the work done. So by saying this is the work done. Work done is a scalar quantity. So I can say potential difference is a scalar quantity. Take note, electromotive force, its SI unit is not Newton, just like a normal force. Rather, the SI unit is voltage. Take note of that. The SI unit for electromotive force is not Newton, is voltage. So this is not actually a push or a pull. This is a difference in the cell when it's not delivering current. Take note of that. Now, this we said it is the work done to move a unit charge from one point to another in the circuit. So the work in moving a unit charge from one point to another in an electric circuit is called the potential difference of that cell. So now, what about this? We have some terms that we need to know. For instance, I have here terminal PD. What is terminal PD? It is the PD, that is the potential difference when the cell is delivering current. Now remember, we have it is not delivering current. We call that an open circuit. Now, when the cell is delivering current, it's now called a closed circuit. So a cell that is delivering current is called a closed circuit. A cell that is not delivering current is called an open circuit. How do you know this? There is a part of an electric circuit called the key or the switch. When it is open, current is not delivered through that channel. But when it is closed, current is delivered through that channel. I'll show you some questions to help you know that. So now we said terminal potential difference is that potential difference when the cell is delivering current. That is a closed circuit. Note that terminal potential difference is less than EMF. Take note of that. And we use V to represent terminal potential difference. Now take note of this. Why is it less than EMF? Is because of the internal resistance that it provides. It opposes the flow of current that it produces. So you see it here. I'll tell you that internal resistance, which is small letter R, is the small resistance the cell itself offers to the current produced. That's internal resistance. So the reason why terminal PD is less than EMF is due to the internal resistance that it produces. Now take note of this. I have EMF minus terminal voltage or terminal PD is equal to loss volt. I repeat again, EMF minus terminal PD is equal to loss volt. So what is loss volt? Loss volt is current times internal resistance. Loss volt is current times internal resistance. Now look at this. I have E minus V is equal to I arrow. So I arrow is our lost volt. Now you know I can now say where where V equals I arrow, voltage equals I arrow. So therefore I will now have E is equal to I arrow plus I arrow. So therefore EMF is equals I open bracket arrow plus arrow. Now look at this very well. So EMF is equals current open bracket internal resistance plus external resistance. So this is the internal resistance of the cell, while this is the external resistance of the cell. Now you see what is the difference between PD and EMF? PD is the voltage across the circuit when current flows, while EMF is the total energy provided by the source. The total energy provided by the source is called EMF. So we'll be looking at the connections of EMF and internal resistance in series and in parallel. Thank you. Now let's see EMF connections. Now we have a series connection of EMF and we have a two different case. What's the two different cases here? We have one positive, negative, positive, negative, positive, negative. But look at this second diagram. Positive, negative, negative, positive. So the arrangement has been changed, but this one is following a sequence. Positive, negative, positive, negative, positive, negative. So for this case, the total for this case, the total EMF, E total, is equal to E1, that's EMF 1, plus EMF 2, plus EMF 3. So once you have batteries connected in series, the total EMF is gotten like this. But if the terminals were exchanged, if the terminals were exchanged like this, now our total EMF is now equal to E1 minus E2. Take note of this, very important. This one, the terminals were exchanged, but this one follows a regular pattern. Now, what about the internal resistance? For this case, internal resistance, which is arrow total, small letter arrow total, is equal to arrow 1 plus arrow 2 plus arrow 3. Take note of that. Very important. Take note of that. Now, what about in parallel? This is in parallel. In parallel, look at this, in parallel. Now, take note for this, we still use the same case. We use this to do the total internal resistance. Now, what about in parallel? This is in parallel case. What is the E total in parallel? Take note, the E total is equals EMF 1 is equals EMF 2. So the total EMF in this cell is equal to EMF 1 is equal to EMF 2. So once you have EMF in parallel, whatever is one of the EMF is equal to the total EMF. Take note of that. What about the internal resistance? 1 over arrow total is equals 1 over arrow 1 plus 1 over arrow 2. So this is how we calculate when they are in series and they are in parallel. So we'll look at some questions now to portray these points. Now let's look at efficiency of a cell. What's efficiency of a cell? The efficiency of a cell is the work output over the work input times 100 over 1. Now look at this very well. It's very important to know this. Let the work output, remember, let the work output equals voltage. Let the work output equals voltage, and let the work input equals EMF. Now take note, work output equals voltage. Remember the work done in moving a charge around the cell. Voltage, let the work input, the internal energy in the cell, be EMF. So now what will now be efficiency? Efficiency is now equal to voltage over EMF times 100 over 1. Now, what is voltage? V is equals I arrow. What is EMF? EMF is equals I open bracket external resistance plus internal resistance. So I have here that efficiency is not equal to I arrow over I open bracket arrow plus arrow times 100 over 1. So this cancels out this. So efficiency is now equals external resistance over external plus internal times 100 over 1. We'll be using this formula to show examples of questions, but I want you to note it that the efficiency of a cell, that's the formula to solve it. Now let's see example number 1. Example number 1 says an ammeter reads a current of 3 ampere when resistance is 5 ohms and 6 ampere when resistance is 2 ohms. Find the internal resistance. So to solve question number 1, recall EMF is equals current, external resistance plus internal resistance. So now I will say EMF is equals, what is my current? My current, the first current is when reach 3 ampere, when external resistance is 5 ohms. So external resistance, the resistance here is my big arrow. So now I'll come here, I'll put 3, open brackets, 5 plus arrow. This is the first statement, so I'll call it equation 1. Then the second statement says, and 6 ampere when resistance is 2 ohms. So I have this as E1. So now my E2 is now 6 when resistance is 2 ohms. 2 plus arrow. I'll call this equation 2. Now what about this? Now I will say where E1 equals E2. So I will now say 3 open bracket 5 plus arrow is equal to 6 open bracket 2 plus arrow. Remember, I'm looking for internal resistance. So this becomes 15 plus 3 arrow is equals 12 plus 6 arrow. So take this way, take this that way. So we have 15 minus 12 is equals 6 arrow minus 3 arrows. So this becomes 3 is equal to 3 arrows. So therefore, internal resistance is equals 1 ohm. So this is how you solve question number 1, where you have a case scenario of this. That's how you solve it. Now let's look at question number 2. Question number 2 says the difference of potential difference, the difference of potential between terminals of a cell is 2.2 volts. I come again, the difference of potential between terminals of cell is 2.2 volts. So this is actually describing EMF. When a 4 ohms resistor is connected across the terminal of the cell, the potential difference is 2 volts. What is the internal resistance? Now, you could recall that EMF minus terminal voltage is equals to loss voltage. And we said EMF minus terminal voltage equals IR. Now this becomes, what's my EMF? 2.2 minus what's my voltage? It was told me is 2 volts minus 2 is equals, what is my I? It equals current times R. So therefore, this minus this is 0.2 is equals IR. Now recall, if current equals voltage over arrow, which equals, what's our voltage? Our voltage is 2 over, what's our resistor? Our resistor is 4. So current will be equal to, that will be 0.5. 0.5 ampere. So now I have my current. So therefore, 0.2 is equal to 0.5 times R. That's from here. Now, what is now my internal resistance? 0.2 over 0.5. That becomes 0.4 ohms. So the answer to this number 2 is 0.4 ohms. Now let's see question number 3. It says when a resistance R is across a cell, the voltage across the terminal is reduced. The voltage across the terminal is reduced to two-thirds of its nominal value, of its real value. The internal resistance is dash. How do you attack this question? I want you to take note of this, that V is equals I arrow. Very important, equation 1. Then we also have E is equals I open bracket, arrow plus arrow, equation 2. Take note of these two equations. Very important, very important. Now look at this. What about here? From here, I can say that I is equal to E, that's EMF, over arrow plus arrow. Now, I want to put I equals E over arrow plus arrow into equation 1. What will it now become? It will become V is equal to, what is now my I? Is E over arrow plus arrow bracket arrow. That's what this will become, because I'm putting everything here into equation 1. Now look at what the questioner says. It says when a resistance arrow is across a cell, the voltage across the terminal is reduced to two-thirds of its nominal value. So if the voltage is now reduced to two-thirds of its nominal value, so I will say therefore 2 over 3 of V is equal to 2 over 3, sorry, of E. So this is reduced to 2 over 3 of E is equal to E over arrow plus arrow, all in bracket arrow. So when the voltage is reduced, so the terminal, sorry, we said the voltage is reduced, the voltage across the terminal is reduced to two-thirds of its nominal value. So now I have two-thirds of the nominal value, which is 2 over 3 of E, is equal to E over arrow plus arrow. So if I have it this way, my E can cancel out my E. So therefore, what am I left with? I'm now left with 2 over 3 is equals arrow over arrow plus arrow. That's what you have left. So now I have 2 over 3 is equals arrow over arrow plus arrow. Cross multiply, and I have 3 arrow is equals 2 bracket arrow plus arrow. So 3 arrow is equals 2 arrow plus 2 arrow. Let this come over this way. It becomes 3 arrow minus 2 arrow equals 2 arrow. So this becomes arrow equals 2 arrow. Therefore, internal resistance is equals arrow over 2, or 1 over 2 arrow. So the answer to this question is D. Now, please take note of this. How did I solve this? I said the question told us the voltage across the terminal is reduced to two-thirds of its nominal value. So all of a sudden we now have V is equal to 2 over 3 of E. So this was what I now introduced into this place as E, as V, then is equals everything we have here. Once you have this place, the solution is easy. Now let's look at example number 4. What is the effective EMF of this circuit? Please take note. Positive, negative, positive, negative, positive, negative, negative, positive. So the effective EMF, E total, would have been 2 plus 2 plus 2, because this plus this plus this. But when it comes to this, it will not be minus 2. Take note of that. Why? Because it is alternated. If it was following the same sequence, it would have been plus. So the answer is now 6 minus 2, which equals 4 volts. Take note of this, very important. Take note of this. But let's look at example 5. Example 5 says calculate the total EMF. Now, if you check, this circuit is in parallel. The EMF are in parallel. And we said, now look at this for number 5. We're looking at example 5. E total in parallel is equal to E1 is equal to E2 is equal to E3. That's what we said. When they are connected in parallel, you just take one of them as the total. So the total EMF is 5. Any of them is the same. So the answer is equals 5 volts. That's the total EMF. Now, what about the next question? The total internal resistance. How do we do total internal resistance? We said 1 over arrow total is equals 1 over arrow 1 plus 1 over arrow 2 plus 1 over arrow 3. That's what we said about this. So now what's our internal resistance? 0 0.5, 0 0.5, 0 0.5. So it becomes 1 over arrow total is equals 1 over 0 0.5 plus 1 over 0 0.5 plus 1 over 0 0.5. Then you just do this. What's the LCM is 0 0.5. So this into this is 1. 1 times 1 is 1. Plus this into this 1 times 1, 1. Plus this into this 1 times 1, 1. So I'll be having 1 over arrow total is equals 3 over 0 0.5. So now what do we now have now? Arrow total is now equal to 0 0.5. Sorry, it now becomes, yes, 0 0.5 divided by 3. So this will now become 0 point. Then you have this as this into this. It becomes 1. Then into 2. Then you have it as 6, 7. So you have it as 0 0.167 ohms. That becomes the answer. Now, this can also be solved. This can also be solved, or resistance total equals arrow over N. What is my small arrow? My small arrow is the internal resistance. N is the number of what now? The number of batteries we have. 1, 2, 3 is our number of batteries there. So my arrow total is equal to 0 0.5 over 3, which is the same as 0 0.167 ohms. That can be another way you can quickly solve it instead of following this procedure. Now, let us look at question number 3. It says the total current. Total current for number 3. Number 3, total current. How can I find total current? Remember, EMF equals I open bracket arrow plus arrow. That's EMF. So what's my EMF? My current is now equal to EMF over arrow plus arrow. So my current is now equal to EMF in this question is 5. Is parallel. So the total EMF is 5. So it's 5 over my external resistor is 10 ohms. So it's now 10 plus internal resistor is of the circuit. Internal resistor is 0.167. So my current is now equal to 5 over 10.167, 0.49, 0.49 ampere. That becomes the answer to that question. Now, what about question number 4? Question number 4 said the potential difference. So, question number 4, V equals I arrow. So, V, which potential difference equals, what's our current? Our current is now 0.49 times. What about arrow? Arrow is the external resistor, which is 10 times 10. So, that V is now equal to 4.9 volts. So that's the answer to each of all of these questions that were tested in this diagram. Now let's look at example 6. The efficiency of a cell of internal resistance 0.5 ohms which supplies current to a resistor, a 2 ohms resistor is that. What is EMF? We said EMF is equal to big arrow over arrow plus arrow times 100 over 1. I've explained this before. So what becomes our big R, which is our resistor, external resistor, is now 2 over 2 plus the internal resistance is 0.5 times 100 over 1. So this is now equal to 2 over 2.5 times 100 over 1. So this becomes, you have this to be, take this there, put this is now 5, this is 4, this here 1, this here is 20. So the answer becomes 80%. That's the answer to this question. Take note, some textbook will say it is arrow over arrow times 100 over 1. It's not correct. This is the right way. I have proved the question, I proved this equation why this is a formula. Thank you. Now we'll be looking at Wheatstone bridge, meter bridge, and potentiometer. Take note, the Wheatstone bridge and the meter bridge can be used to determine an unknown resistor, an unknown resistance of a resistor. So you can use the Wheatstone bridge or the meter bridge for it. Now take note of this, that a meter bridge is a form of a Wheatstone bridge. Take note of that. And a Wheatstone bridge works on the principle of Keukel's rule. So please take note of this, very simple and swift. We have this to be my arrow 1, this to be my arrow 2, this to be my arrow 3, why this to be my arrow 4. Take note of this analysis. In what manner can I solve questions from the meter rule? I will compare this to this as equal to this to this. So I will say arrow 1 over arrow 2 is equals arrow 3 over arrow 4. So to solve such a question, my arrow 1 is 15 ohms over arrow 2 is 20 is equal to arrow 3 is my unknown, which is W, over arrow 4, which is 24. So we are looking for the unknown, and this is how we can get our unknown. So our W will now be 15 times 24, 15 times 24 over 20, over 20. So this here is 3, this here is 4, 4 here 1, 4 here is 6. So W becomes 18 ohms. So that's how questions from our Wheatstone bridge can be solved. Take note of this. This is how you solve questions from Wheatstone bridge. You compare this to this as equal to this to this. That's how it is solved. Now, what about for a meter rule? Now, this is a question involving a meter rule. Here is the rule, which is 100 centimeter. This is the rule, which is 100 centimeter. Now, please take note that resistance is equal to resistivity L over A. We proved this equation, we talked about this equation when we were discussing Ohm's law. Now, what does that mean? It means that resistance is proportional to length. So if resistance is proportional to length, so our arrow is equal to KL. So therefore, I have arrow 1, arrow over L is equal to K. So I have arrow 1 over L1 is equals arrow 2 over L2. Now, this can be further simplified to arrow 1 over arrow 2 is equals L1 over L2. Any of these two formulas are the same thing. So if I have a question like this, from 0 to this, but this is called the balance point. From 0 to the balance point is called L1. Then from this point to this final point is called L2. So this cannot be arrow 1 over L1 is equals arrow 2 over, where L2 is not giving me, I can say L2, or I can be arrow 1 over L1 is equals arrow 2 over, where L2 is not giving me, L2 cannot be 100 minus L1. If L2 is not giving me, I will say L2 will not be equal to 100 minus L1. Any of these formulas can be used to solve questions concerning a meter bridge. It can also be this to solve questions concerning a meter bridge. Now look at this question. Now let's solve this question with this analysis. In a meter bridge, 2 resistors, 2 ohms and 3 ohms occupies left and right. This is my right hand side. This is my left hand side. So the left and right. So 2 and 3, left and right. So this becomes 2 ohms, while this becomes 3 ohms, left and right. So now we are not saying find the balance point from the right side of the bridge. So we are looking for this balance point. That's what we want to find, this balance point. So which formula will I use to solve? Let me use this formula to solve. So now what's my arrow 1? My arrow 1 is 2 over, what is my arrow 2? My arrow 2 is 3, is equal to, that's 2 over 3. Arrow 1 over arrow 2 is equal to, now what is my L1? My L1 I don't know, so I will take it as L1 over, what is this point to this point? I don't know this point to this point, so I will make it to be 100 minus L1. So I will say 100 minus L1. So in solving this cross multiply, I have 3L1 is equal to 2 open brackets 100 minus L1. So this becomes 3L1 is equals 200 minus 2L1. Take this way, it becomes 3L1 plus 2L1 is equals 200. So I have 5L1 is equals 200. Now, if you solve this mathematically, so L1 will be equal to 40 centimeter. Now, it means that my L1, this point is 40. This point is 40. This balance point is 40. But that's not the question. The question says, find the balance point from the right side of the bridge. So from here to here is 40. From left to right is 40. But from right to left, here to here will be 60. Take note of that. Very important. So the answer to this question will not be 40 centimeter, rather it will be 60 centimeter. From right to left is 60, but from left to right, the balance point is 40. I reiterate again, from left to right, the balance point is 40 centimeter, but from right to left, the balance point is 60 centimeter. Now we're looking at conversion of galvanometer to an ammeter. First of all, what is a galvanometer? A galvanometer is a device that is used for detecting small current. This is for measuring small current. But an ammeter can measure a larger current. So now we are converting a galvanometer to an ammeter. How it does this work? Now let's assume this diagram. This is a galvanometer. Now let's assume this. Now, this galvanometer is sensitive enough to read 1 milliampere. 1 milliampere. What is 1 milliampere? That's 1 over 1000 ampere. So, this galvanometer can read this particular current. Now, I now have a huge current of about 10 ampere coming into this galvanometer. Now, what will happen if I allow this 10 ampere to run into this appliance? It will blow it off, because what it is able to read is 1 milliampere, which is 0.001 ampere. Now, it means that to salvage this effect or this damage from occurring, what happens is that if I build a resistor in series to this galvanometer, I have not done anything good. Why? Because the current will come in here and leave and still come here, because in series they will have same current but different voltage. So connecting it in series is not a right step. So what's the right step? I will connect a resistor in parallel to the galvanometer. Why connect in parallel to the galvanometer? So that at this junction, the current that this can read will go in, while the remaining current will come here. So I have been able to break this 10 ampere into two. I have a particular current coming in here, which is this. That current is called the current of the galvanometer. That's what it is called. Then why the one that is coming here is called the current of the shunt. What is a shunt? A shunt is a low resistance wire, a low resistance wire connected in parallel to the galvanometer. A shunt is a low resistance wire connected in parallel to the galvanometer. So the shunt will not take some current out of the total current. So let this one be my total current. This is my standard, my total current is equal to 10 ampere. Then this is now the current of the shunt, while this is the current of the galvanometer. Now, what will not be the current here? The current here will not be 10 ampere, which is the total, minus this that will be here, which is now 0.001 ampere. Now remember, 10 ampere was coming. Now only what this can hold went to this direction, which is 0.01 ampere. Then the remainder is going to come here. So what is that remainder? The remainder is now equal to 9.99 ampere. So 9.99 ampere is here, while 0.001 ampere is here. So if you add both of them together, it will equal to 10 ampere, which is the total. So it means this is now the current of the shunt is equal to the total current minus the current of the galvanometer. Now take note of this. Once you understand this mechanism this way, it is very easy to solve. Why? Because once I know my current here and I know my resistance here, I can solve for my voltage here. When I know my current here and I know my voltage here, I can calculate for my resistance here. Now, note this, that these two components, they are in parallel. So they have the same voltage but different current. They have the same voltage. The galvanometer and the shunt, they have different current. 9.99 ampere, 0.001, 0.001 ampere. But whatsoever is the voltage here is equal to the voltage here. So I can easily solve for the resistance of the shunt and for the resistance of the galvanometer, because Ohm's law states that V equals I arrow. So that will help me to find this or find, because majority time the question will say calculate the resistance of the shunt. So if I know the current of the shunt, I can know that, okay, the voltage of the galvanometer is this, therefore the voltage of the shunt is this. So what am I trying to say? I'm trying to say that the voltage of the galvanometer is equal to the voltage of the shunt, but the current of the shunt is equal to the total current minus the current of the galvanometer. Very, very important. But the current of the shunt is not equal to the current is not equal to the current of the galvanometer. Take note, they have the same voltage, but they don't have the same current. Very, very important. So I will not say if the current of the galvanometer is if the voltage of the galvanometer equals the voltage of the shunt. Therefore, it means that if V equals I arrow. So I will now say that the current of the galvanometer times the resistance of the galvanometer, because V equals I arrow. So in place of V, I'm putting I arrow. So current of the galvanometer, resistance of the galvanometer is now equal to, now this will now be current of the shunt and resistance of the shunt. So now, what is the resistance of the shunt equal to? The resistance of the shunt will now be current of the galvanometer times the resistance of the galvanometer over the current of the shunt. Please, I hope you remember that the current of the shunt is the total current minus the current in the galvanometer. So I cannot say that the current in the shunt is equals IGRG over total current minus current in the galvanometer. This can be used to solve this question if you don't want to use the normal simple application where you say, I know the current here, I know the voltage here, I can find the resistance. I know the current here, I know the voltage here, I can find the resistance here. So I will be solving questions to show us how we do this. But before then, let's look at conversion of a galvanometer to a voltmeter. Now look at this. It's still very simple. Now this is the galvanometer. Now look at a total voltage coming. V total is coming. Now you know that if this has a particular voltage, it can read. So this becomes the voltage of the galvanometer. Now to make sure that this total voltage is not harmful to the voltage that the galvanometer can read, what do? I connect a resistor in series. This resistor is called a multiplier. It's called a multiplier. Why connected in series? Why not in parallel? Because in series they have different voltage but the same current. So it means I have the V of the multiplier, voltage of the multiplier, and I have the voltage of the galvanometer. So my total voltage is equal to the voltage of the multiplier plus the voltage of the galvanometer. But the current in the multiplier is equal to the current in the galvanometer because they are in series. So what is a multiplier? The multiplier is a is a high resistance wire. A shunt is a low resistance wire connected in parallel. A multiplier is a high resistance wire connected in series to a galvanometer. So to convert galvanometer to voltmeter, you use a multiplier. But to convert galvanometer to ammeter, you use a shunt. So from here, I will use this formula now to solve. So my V total is equal to, I can simply say, my I multiplier times my arrow multiplier, because V equals I arrow and I'm dealing with multiplier, then plus my VG. Whatsoever is the formula ask you, whatsoever is the question ask you, you can use this relationship to keep going down and to solve your unknown. Most of the time, the question is always calculate for the resistance of the multiplier. That's most of the time the question that is being asked. So from here, you can easily take this way and divide by I. That becomes the resistance of the multiplier. So this is a picture of converting galvanometer to ammeter or galvanometer to multiplier. Now let's look at this example. The diagram shows the conversion of a galvanometer to a galvanometer of resistance. I read again. The diagram shows the conversion of a galvanometer of resistance. So this is the resistance of the galvanometer to an ammeter. The galvanometer gives a full-scale deflection for a current. So this is the current of the galvanometer, 10 milliampere. Calculate the value of R. So this is the total current that is coming. 10 ampere is coming. That's the diagram. That's what the diagram shows. Then the current that this can read is 10 milliampere, which equals 10 over 1000 ampere, which is 0.01 ampere. So take note, what this galvanometer can read is 0.01 ampere. The total that is coming is 10 ampere according to the diagram. And the resistance of this galvanometer is 2 ohms. So the resistance is 2 ohms. So it means I know the current of the galvanometer is equal to 0.01 ampere. The resistance of the galvanometer is 2 ohms. So I can be able to find the voltage of the galvanometer. V equals Ig, then ROG. So VG, which is the voltage of the galvanometer, is equals 0.01 times 2. My answer here becomes 0.02 volts. So if the voltage of the galvanometer is 0.02, and I know that in parallel they have the same voltage but different currents, so I will say note. What do I want to note? The voltage of the galvanometer equals the voltage of the shunt, because this is the shunt, and that's what they want us to calculate the value for R, which is the resistance of the shunt. So what will I do? So I will say, therefore, V of the shunt is equals I of the shunt, then arrow of the shunt. So arrow of the shunt is now equals V of the shunt over I of the shunt, which equal to, what is the voltage of the shunt? It's the same thing as voltage of the galvanometer, which is now 0.02 over, what is the current of the shunt? The current of the shunt, I don't know, but I will know it from here, because the total coming is 10, that of the galvanometer is 0.01. Therefore, the current in the shunt will be 10 minus 0.01, which equals 9.99. So my current here will be 9.99. So therefore, the resistance of the shunt will be equal to 0.02 over 9.99, 1212, which equals 2 over 999 ampere. That's the answer to this question. Another way to solve it is, or remember, we said the resistance of the shunt is equals current of the galvanometer, arrow of the galvanometer over total minus Ig. That's the formula we gave, not quite long. So this will now be equal to, what's the current of the galvanometer? 0.01. So it's now 0.01 times, what's the resistance of the galvanometer? Look at it here, is 2. Current of the galvanometer is 0.01. Resistance is 2 times 2 over, what's the total current coming? Look at it here from the diagram, is 10. That's 10 minus, what's the current of the galvanometer? Is 0.01. So now arrow x is now equal to 0.02 over 9.99. The answer is 2 over 999 ampere. The same thing with what we got. Now let's do question number 2. It says a galvanometer of resistance 5,000 volts. So we have resistance of galvanometer equals 5,000 ohms. Is calibrated to read 1 volt per division. So the voltage of the galvanometer is 1 volt. That's what we have in the question. Now, if the instrument is required to read 10 volts per division, so what we are having now, we have the total voltage that is coming is equals 10 volts. Then we're now asked what series resistance must be connected to it. Now remember that we have a multiplier connected in series to the galvanometer. Remember, that's how it looks like. So these have a resistance of 5,000. Then this again has a voltage of 1 volt. Remember, they have different voltage, and the total voltage that is coming, the total voltage coming is 10 volts. So if here is 10 and here can read 1, what will now be here? So this will now be 9 volts, which is 10 minus 1 is 9. 9 plus 1 equals 10. Now, what do these guys have in common? They have the same current, but different voltage. You can see the voltage are different. So now, what is the current here? I cannot say I is equals V over R. So which equals, what's my V? 1 over 5,000. So that's my current. So now if I come over here, then I want to now solve for my resistance here. Resistance is equal to, now you know that V of the multiplier equals I of the multiplier times arrow of the multiplier. That's this formula here. Now to get the resistance here, I will now say resistance of multiplier. That's what my question is asking me. What resistance will be calculated for, or will be of this instrument here? So resistance of multiplier is equal to voltage of multiplier over current of multiplier. So resistance of multiplier is equal to, what's my voltage? My voltage is 9 divided by, what's our current? Remember, our current is 1 over 5,000, which is now equal to 9 times 5,000 over 1. So the resistance of multiplier is now equals 45,000 ohms. That's how this is solved. If you understand it, Very well. Another way I solved it, I said V total is equals V of multiplier plus V of galvanometer. The voltage total is equals the voltage of the multiplier plus the voltage of the galvanometer. So now our V total is equals I of multiplier, R of multiplier plus V D. So now V minus VG is equals IM ROM. What is now RO multiplier? Is now V minus VG over IM. So now what is our RO multiplier? The resistance of multiplier is now total voltage is 10 volts, which is 10 minus voltage of the galvanometer is 1 volt, which is 1 over current of the galvanometer. Look at it here. We solve for it as 1 over 5,000 is 1 over 5,000. So now R is now equals 9 divided by 1 over 5,000. So that would now be 9 times 5,000. The answer is 45,000 ohms. So you see that's how this is solved, converting galvanometer to voltmeter. Thank you.